Hey everybody and welcome back to Jim's Garage. In this video I'm going to show you how to use your existing Proxmox setup to create the ultimate cheap bare bones NAS. That's right, we can use the existing Proxmox setup to create a ZFS RAID that we can pass through to a virtual machine and spin up a lightweight container, creating a Samba share. Now, to get this up and running, it's going to be pretty minimalist, and you might even have the requirements already. In this instance, I'm going to get 2 additional drives. Don't buy these, they're terrible. And I'm going to set up a ZFS RAID within Proxmox. I'm then going to assign this as a volume within a virtual machine, and then install Docker so that we can deploy a container and reference that storage space. That's great because under the hood, we know that we've got ZFS RAID backing up all of our data. And you can extrapolate this as far as you want. You could add more disks and create more redundant arrays. Just choose something that you can afford and fit within your machine. Now, why might you want to do this? Well, I'm a big fan of TrueNAS. I think it's excellent and I'm not going to be changing it anytime soon. But that's because I'm fortunate and I have some dedicated hardware that I can set aside to do that. But if you don't have that or you simply don't require it, it has a few benefits. Firstly, you're not going to need an extra machine. You can use the machine you already have. Secondly, if you've been following my videos, I've showed you how to do a virtualized TrueNAS. But again, that requires additional hardware with an HBA. This, it doesn't require that. We're going to create the ZFS on Proxmox and then we're going to pass that through to a virtual machine. So to demonstrate this, I'm going to be using my Dell R730 simply because it has a number of SSD slots that can accommodate this and because it supports hop swapping, which makes making this video easier. But the process for getting this up and running on something less enterprise is pretty much the same. And you'll have seen me do this in my NAS build before. Essentially, you're going to need to plug these into your SATA connections on your machine. And then we're going to select those and create a ZFS RAID from them. And the steps I'm going to detail should be applicable. So I'm going to show you what my Proxmox storage looks like now. I'm then going to install these drives into the machine. And hopefully those will be picked up in Proxmox and we can begin the ZFS RAID process. So here over in Proxmox, you can see my existing storage within my Dell server. You can see that I've got the quad NVMe, which I've discussed before, which is my super fast storage for all of my virtual machines. And then I've got SDA and SDA-B, which are my SSDs where I have Proxmox installed. So I have a mirrored RAID for my Proxmox installation, just in case that boot drive went down. I've now transferred these to their caddies for my Dell, and I'm going to insert them into the machine, and fingers crossed they're automatically picked up. If they're not, and this might be more typical on consumer equipment, you'll simply need to reboot your device and they should be listed here. So fingers crossed, here we go. So now with any luck, we should be able to hit reload and see those new drives. Let's give that a whirl. So reload. Yeah, there we go. We've got SDC and we've got SDD. Now, those have already got some data on, so they're going to be wiped during the ZFS process. Just bear that in mind. Don't use any disks that you've got data that you care about. So how do we create the ZFS? So in my instance, before we get started, I'm going to wipe this disk. So SDC, I'm going to hit wipe disk and click yes. And then I'm going to repeat the process for SDD. So that's here. Wipe this disk and hit yes. Now that our disks are wiped, we can create the ZFS itself. So to do that, on screen already, you might see ZFS. So we want to create a new one. And you'll probably see a couple here already, the R pool being the one that my Proxmox is installed to, and the NVMe being my quad NVMe ZFS pool. So if we hit create ZFS, it's going to list the 2 drives that aren't used by any existing pools. So I'm going to give this NAS as its name, and I'm going to select the drives that I have here. Now, I can't choose RAIDs because I don't have 3 disks. Remember, there's redundancy here, but if you have 3 disks, you can obviously benefit from that. So to kind of cheat with my setup and 2 disks, I'm just going to choose a mirror. But I do recommend RAIDs because it's going to give you redundancy and the ability to expand this in the future. So moving over to the bottom right, I'm going to hit create. And now that's created our mirrored RAID pool. So now that we've got that, we can actually begin to use it. And in Data Center, we can see that we've got NAS up the top, and it's set to allow disk images and containers, which is what we want because that's going to allow us to specify this in the VM. If you wanted to, you could edit this and reduce those two options, or if you wanted to add more to it, you'd need to add a subdirectory assigned to this ZFS with the relevant path specified, similar to how I've got here mount PV TrueNAS and mount PV NVMe ASUS. And once you've done that, you'd be able to add things like your backup files, your dumps, etc. So now that we've got the NAS available as a data, we can head over to this VM I've created. And this is just a virtual machine created using my cloud in it. You can go and find out how to do that, but it makes creating virtual machines really simple. So on the hardware tab now, you can see that by default it's created a hard disk with 10 gigs of space, but we now want to add our new drives. So hitting add and then hitting hard disk. You can see that we can assign it. I'm just going to leave that as SCSI1 because SCSI0 is already taken by the boot drive. And then we can see here storage. So I'm going to click NAS and yeah, fine, 32 gigs works for me. You could obviously give it more space. Now I'm going to turn on the discard for this one because it's an SSD, and I'm also going to do the SSD emulation. So that now means that it's going to reclaim some space as and when required. And then I'm going to click add. So now we've got this secondary hard disk here, and we know that under the hood, anything that gets written to this drive is actually mirrored with ZFS. And we can add additional drives. In my case, that's just going to keep creating the new mirror. But if you've got something like a RAIDs 1 or a RAIDs 2, again, there are a minimum number of drives you'll need for each of those. A RAIDs 1 is going to mean that one of those drives can fail and you're okay. A RAIDs 2, 2 drives, RAIDs 3, 3, you get the idea. But now importantly, we can start this machine up. I'm going to let the Cloud Init process finish. But once this process is finished, we're going to verify that we've got the volume we assigned to it installed, and then fingers crossed, we should be able to install Docker and start using it for our container mounts. So I'm going to let this run and I'll see you on the other side. And so now that installation process has finished, and just a reminder, this is using a cloud image which behaves a little bit differently to the default Ubuntu installation or whichever flavor of guided wizard that you'll be using for a desktop or server image. But once that's completed and I run an lsblk to list the storage devices, you can see here at the bottom that SBD, I've got here 32 gigs, which is that disk. We've got SDA, which is the original 10 gig, and then this one here, which is now backed up by our NAS, or in this case, our Proxmox ZFS Pool. So now that we've got the infrastructure sorted, let's hop into how we're going to do this in terms of Docker. So whilst we discuss that in the background, I'm just going to make sure that Docker's on here, but if you've been following my videos, you should already have Docker installed. Additionally, you could take your existing virtual machine. So for example, over here, I have my Docker VM. This is 1.11. I could go to the hardware tab and then I could shut this machine down and then I could click add a hard disk. And then again, I could select that NAS and then assign some storage to that. Then on the next boot up, I'd need to mount that and make sure that it's usable as storage space. So now I've installed Docker and good old Portainer. We're in a position to start using our newly added drive, but there's a few things we need to do first. Most likely, you're going to need to format this drive before you can use it. Then you're going to need to create a position where you want this to be mounted to. And then finally, you're going to mount it to that position or folder in this case. So let's go now and format our new drive first, otherwise we can't use it. So to do that, I'm going to format this disk by Makefile System extension 4, and then I'm going to do /device and then SDB, which if you remember back to when I ran the lsblk command, we know that the device we've added has come up as SDB. So hitting return on that, everything looks fine, it's gone away and formatted it. The next thing we need to do is to do a sudo make dir and then / I'm going to call this one SMB. So when I create this folder, it's going to put that in the root directory. And then once I've done that, I can do a sudo mount. And then I want /dev /sdb. and then the location I want is /SMB. So now when I hit return, that should have mounted those drives to that folder location. Great. Now that we've got that, we can jump into the container. So as always on my channel, I'm going to give you an overview of the container itself. So the Docker Compose, I'm going to show you some of the variables and what I've got them set to. We're also going to look at the config file because that's going to be important for our Samba share, because that's where we set up all of the users and the permissions related to this. So what's really cool is, although we've created a /SMB folder, you could share the entire root of that folder if you wanted to, or you can create any type of subdirectories and folder permissions that are accredited to each one of those. So you could have multiple users all assigned access to different folders. This can also be done with NFS, and I'll link a container in the bottom that you can do this with. Do bear in mind that you don't have to use Docker for this. You could just install a bare VM or an LXC and install the Samba server itself, and the process will be pretty similar, but I prefer the simplicity and the repeatability that comes with Docker, and the fact that you can just run a single compose file and have all of this up and running. So over in VS Code, let's have a quick look at the compose file. So I'm using the image by Crazy Max, thank you, and I've had a quick look at this, and it uses the latest version of Samba with all of the security fixes applied and all of the latest features. So go ahead and give it a name. I'm going to leave it as Samba, and then importantly we get on to the volumes. So this first volume here, this /data folder, this is where the cache configurations and runtime data are. So this isn't a mount location for your data. Now change this to wherever you want it to be. If you leave it with a ./, it's going to put it in the same folder as your compose file. And then the /public is the bit that we want to change. Now this is your actual Samba share. So here I'm going to change this to, if you remember, I changed it to /SMB. So now that /SMB folder on my host is going to get mapped to this public Samba share within the container. Great. Remember, as I said previously, if you have lots of different shares that you want to be sharing, you would simply add more. Now, I've left in some examples here from the example compose file so that you get an idea of what that might look like. You'd simply need to map these on the left to wherever they reside on the host, and then on the right hand side you would need to give it some name. We'll come on to that in a moment because, as I said before, there is a config file here, so things like share, foo, baz, whatever, you'd have real names of course. Those are all mapped out in here. But let's finish the compose file first. So it takes a number of environment variables, and I've only specified 2 in my example, but do know all of the ones that are commented out you could tweak if you wanted to, if you've got a more exotic setup or you want to try and restrict this in some way. So all I've set is the time zone to Europe and the log level to 0. You can obviously increase that if you want more verbosity in your logging. Now, of the ones that are commented out, there probably aren't too many that you want to change. By default, it's going to use the workgroup name for the SMB share, and I recommend keeping that as because that's the default. You may also want to give it a server string if that's something that's helpful for you. The other thing that's important is perhaps the Samba hosts allow. So by default, it's going to allow anyone, but if you only wanted to accept connections from certain hosts, a little bit like a firewall, you could specify the specific IP addresses or the IP arrangers that you care for. So by default, it's going to accept anything local on your LAN, but if you want to restrict that to just a subnet or a given machine, go ahead and do that. By default, it's going to listen to all interfaces, and then there's a number of settings that you can put here, whether it does WSDD2. Now by default, that's not set, and there's no string assigned to that, but you can assign those if you wanted to. I've set this to restart always because if it's a NAS, we're probably going to expect this to be on 24/7. So now we've gone over the compose, which is pretty straightforward. Let's have a look at the config, because as I mentioned, the config's important because this is where we can set the people and the share volumes. Now looking through here, I'm going to go with the following setup with just a couple of tweaks. Now, you can tweak this to whatever you need and however many users you want or however many directories you need, but let's have a look what's going on here. So at the top, we've created a user of foo in the group foo with an ID of 1000, which is what my current user is within my Docker environment, and I've set a password of bar. Now, you could have another user. For example, in the documentation, they use Baz. This person will have a different user ID and potentially a different group ID, which then would give them different permissions on the share if you want to set that up. Now, the global settings are to force the user of foo. And then in this instance, we're creating one share. Now, this share is called the public, which if we go back to the Docker Compose, you can see we mount here. Now, because this is a public, it comes with some defaults. So the path is /samba/public, which is what we specified in the compose file. We've said that it's browsable, which makes sense if it's public, and it's read-only yes. Now, I'm actually going to change that to no, just because I want to demonstrate writing to this. But in your instance, you may want to go and create another share down here, which is, as you can see, the example of read-only no. And that is going to be assigned to somebody like Baz, for example. And now, hopefully, this will give us the ability to demonstrate reading and writing to and from this directory. So now that we've got this set up and you understand how to create new users and specify new shares and have all of those options within those shares, let's copy it over and let's get this container up and running. As a little sneak peek, I am going to show you how to copy these files over and launch containers within VS Code, so watch out for that. And so now that we've done that, you can see on this machine here, which is this one in the background, I've created an SMB folder, I've put the Docker Compose file in there, and I've created the subdirectory for data with the config file in, which is what's expected as the default in here. You can obviously change that to whatever location you want. And now we're in a position where we can start this container, so let's get on with it. So now I'm in the right folder, I'm going to do a sudo docker compose up-d, and with any luck, this container should start, and it should start serving that SMB share. So it's pulling down that container, and then very shortly we'll be able to test if this is up and running. I'm going to jump into Portainer and just check the logs just in case. So over on my new instance of Portainer, I'm going to go into the logs and let's have a look what's going on. So we can see that the container started successfully. It's added those users. It's used the config file we specified, and then it spat out all of the configuration that we had. That all looks good, and if we scroll down, the hosts allow looks good. You can see those default values. The public share looks okay. Everything's done. The service is starting. Great. And you can see that we're on version 4.18.9, which I believe is the latest version. So, fingers crossed, we should now be able to go into Windows, for example, and mount this as a share location. Let's go and do that now. So in Windows, if we right-click this PC and then we click Map a Network Drive, we get some options to do that. So you can choose a drive letter to use. I'm just going to use Y because that's available on my machine. And then we're going to need to do a // the IP address. In this case, it's 192.168.200.183. I recommend you make this a static IP for obvious reasons, and you can even use a DNS name if you wanted to. And then I'm going to do a /, and we need the share name. So if you remember, I think we called this one public. So we'll call this one public. And then we're going to need to use different credentials for this, because by default, it's going to use your Windows credentials. So hitting finish, it's asked us for what it is. And I believe it was foo for the user and bar for the password. You probably want to remember your credentials so that you don't have to type this in every time. And it should also mean that it will automatically reconnect to this drive every time you start your machine. So hitting OK, bingo, we've got our share. And it really is that simple. So now we have an SMB share running in Docker that the underlying hardware is on a ZFS RAID. And we haven't had to spin up a new virtual machine in terms of something like TrueNAS, and we haven't got the overheads of additional hardware, i.e. a whole new machine, and all of the power costs that come with it. And with ZFS RAID, you can add new drives and new pools, VDEVs, etc., and expand this as far as you need to. Now, testing this out, you might run into the following problem. So if we go new, and then we say a text document, we don't have access. Our permission here was denied. So what can we do? Well, it's probably because if we check the folder permission here and we hit properties, we can see that it's probably set up something like this, where other users don't have the ability to write or execute. So if we hop into the terminal, we can change these permissions to match whatever we want. Now, I'm going to give you the overlaying just give me everything, which would be 777. I recommend you tweak this to whatever users you want and their respective permissions and the respective subdirectory as well. But just to demonstrate this, if we set it to 777, so now everybody's got permission to do anything to this folder. If we head back now, we can right click and we should be able to hit new and then a text document, and there you go, we've created it. And that's in there. And then if we want to create something in here, I'm just going to put the text of test. And now if I save that, hopefully if we now go back into our terminal, we do a cd/smb, and we do an ls, we've got that new text document. And if we nano that new text document, we can see that we've got test inside. Excellent. And if we want to test that, we can do something else. We can save that, and then hopefully if we open that up again in Windows, we'll see that we've now got that new text. So brilliant. Everything seems to be working across Linux and Windows, and we've got that share mounted. So now you have all of the tools you need to create a bare bones NAS on your existing hardware. Obviously that comes with all the benefits of you pretty much have everything you need already, and it's going to be super minimalist. Now obviously you can run this as just a Samba share on Proxmox. I don't really like that approach because I want Proxmox to do what it does best. That's hosting VMs. And anything else on top of that is going to add additional complexity, possibly break things, and cause more of a nightmare to actually solve the issues. I'm not saying don't go and do that, I'm just saying I don't want to take that risk. You could also do this through an LXC if you wanted to, and that's really lightweight, but I prefer to use my existing Docker setup because I have that, and I love the repeatability of Docker Compose. So let me know if this is something that you're going to do in the future, and I might come on to NFS if you need a tutorial for that, but for now I'm going to wrap it up here. So if you've enjoyed this, please give it a thumbs up, hit that subscribe button, and I'll see you all soon. Take care, everybody.